Hello everyone, so I hope you're doing okay. In this video, we are going to continue our discussion about the heterocyclic chemistry. Now, if you have watched our previous video, you know what we are talking about, right? So we have started about the nomenclature. Now, this is our second part of our video series. If you have not watched our previous video, which we have talked about the first type of the nomenclature, which here we have talked about the replacement nomenclature in our previous video. So if you have not watched that video, I will put the link here so you can go through and watch it if you need it. And now in this video, we are going to talk about this Hantzsch-widman nomenclature. So it's a little bit hard for me to pronounce this word, so don't mind it. We are going to talk about this nomenclature method in this video. So this is more like a standard method compared to our previous replacement nomenclature method. But again, there are some similarities and also for some this is more complex compared to the replacement nomenclature. But when you familiar with this nomenclature, when you familiar with the names, structures and whole process, it's pretty much easy. So we just need to practice a little bit. So let's move on. Now there are few things again we need to keep in mind when it comes to the nomenclature. The first of all, this is the most important thing. So the same words like here applies to the our current method also, right? So this is the word that we have used for the oxygen, sulfur, selenium, tellurium, likewise. So you need to have a good idea about this, at least for these oxygen, sulfur and nitrogen, because these three atoms are the most common heteroatoms that we may find in our cyclic compounds. Now other than this, there are some other words that we need to keep in our mind. So in this case, right, if you remember our replacement method, the whole ring, we have used the fundamental organic chemistry methods, right, like propane, hexapropane, cyclopropane, cyclobutane, likewise. But in this case, the ring has a separate name. So if, as an example, if we have a four-membered ring, right, if we have a four-membered ring, there are two words that we can use based on the saturation of the ring. So I hope you know what is saturated and the unsaturated means. Now if a ring is saturated, right, if the ring is saturated, it has no double bonds. This is a saturated ring. This is a saturated ring. If we take this ring, this is unsaturated. Okay, this is unsaturated. So let's say we are having a four-membered ring and our ring is unsaturated like this. So this is our ring. It's unsaturated. So in this case, you need to go with the word ET, right? So ETE, which is the word that we have to use. So we will do some examples so you can exactly see how these words apply to the whole name, right? So we just need to keep our mind on this particular table. Now if I take a particular example, let's say let's take this one. Okay, now first, as we have done in our earlier video in our replacement nomenclature, first we need to identify the heteroatom. So in this case, the heteroatom is an oxygen. There's only one oxygen is there. So the oxygen, the word for the oxygen is ASA. So here in this table, sorry, yeah, I did something wrong. It's not ASA, it's OXA. Here, it's OXA. Word for the oxygen is OXA. Now we have the name for the heteroatom. As you can see, there's only one heteroatom. So no need to mention the position of our heteroatom, but ring is unsaturated, right? The ring is unsaturated. So in this case, we need to go here. We have a 5-membered ring, 1, 2, 3, 4, 5 5-membered ring here. 5-membered ring and our ring is unsaturated, so the word is all. So we need to add all to this initial word. So the total will be, not the total, like the whole word will be oxazole. Oxazole, like I mean oxole, sorry. Oxole. So this structure, the name is oxole. This is how we do the nomenclature in this case. Let's do another example. So how about this one? Now in this case you can see the nitrogen is there. So first we need to go to this table and see what's the word for the nitrogen. Asa is the word. So we come here and we write Asa. And now we need to join this Asa word, right, the nitrogen atom, with the word for the cyclic compound, right, otherwise our cycle, right. So here we have 1, 2, 3, 4, 5-membered ring and our ring is unsaturated. So here we have 5-membered ring, unsaturated ring system, which means the word is all. Now when we combine these two, we have azole. This is the word. This is the name for this particular compound. Okay, what about this one? Here we have nitrogen. Now we have nitrogen, right? Nitrogen means we have Asa. Don't forget that we have now two hetero compounds. Sorry, we have two heteroatoms. So when you have more than one heteroatoms, you always has to mention the position. So here we have to mention the position. Now I will put the number 1 for this nitrogen atom. If you don't like it, you can put the number 1 for here. If you put the number 1 here, then this comes number 2. So here number 1, number 2, 3, 4, 5 and 6, and the positions are 1 and 3. And let's go with the members, like I mean for the cyclic part of the compound, we have 6-membered ring and it's unsaturated. So here we have the 6-membered ring. Unsaturated words for the 6-membered ring is ene. So Asa we need to add ene. Don't forget we have 1 and 3 positions here. So we have the total name, otherwise the combined name is 1,3-diacene. Acene, sorry. We can't say diacene because 2 are vowels, right? Basic English, I guess. So it's diacene. And then what about this one? Sorry. Okay, what about this compound? Now we have 2 heteroatoms, right? We have 2 heteroatoms. Again, remember, when you have more than one heteroatoms, you need to mention the position. So I have told this number in the positions when you have more than one heteroatoms in our previous video. So we have 2 kinds of heteroatoms, nitrogen and oxygen. So we need to look at the more dominant one. So according to this table, the most dominant is the oxygen, then sulfur, selenium, tellurium and then nitrogen. So order is first oxygen and then nitrogen. So here first you must look at the oxygen and then the nitrogen. Now I will put the 1 for the oxygen, right? Now in this case you can put the 1 for the nitrogen, right? Because oxygen is the more dominant one. So you need to give the first number for the most dominant heteroatom. So here we have the oxygen, it's the number 1, and here we have the number 2. 3, 4 and 5. And we have two heteroatoms, right? So let's see. We have two heteroatoms, oxygen which is oxa and nitrogen which is asa. So we have oxa and asa. Both are here, and we have 1 and 3. These are the position, 1 for the oxa and 3 for the nitrogen. And remember, first we need to mention the positions, and second we mention the names, and finally we mention the ring. Ring is 5-membered ring and it's unsaturated. Here 5-membered ring and it's unsaturated, so the word is all. Now when you combine this name together, it's 1,3 oxazole. Oxazole. 1,3 oxazole. Now I think you may begin to see the difference between the two nomenclatures, right? So here the nomenclatures are more shorter, right? It's much more easy to remember, much more easy to document it. So this is why we are considering this Hantzsch-widman system as more standard nomenclature. Like, it's more shorter and it's more professional. That's why. But again, both of these nomenclatures are correct and both are acceptable. But when it comes to the exams, your question may specifically ask for the specific nomenclature, right? So sometimes the name would be given to you and you may ask to draw the structure. So you have to familiar with the both of these systems, right? So I highly recommend you to go online and find some exercises. There are a lot of exercises online, and also you can do the same exercises again and again to obtain more practice. So when it comes to these nomenclatures, don't worry about the heteroatoms, because the common heteroatoms are nitrogen and oxygen. As you can see here, you have not found even the sulfur. So I highly recommend you to focus on nitrogen and oxygen and also sulfur. That's the most of it. Like 90% of the compounds we have in our level are based on nitrogen, oxygen and sulfur. And there are also some, let's say, honorable mentions, right? So there are some compounds which are more common, like they are essential in our day-to-day life. So common people, like most of the people, tend to call those compounds in more common name, right? Other than this 1,2-dimethyl, like those standard names, they tend to go with more common names. The most, like how can I say it, right? Okay, this structure, I hope you know this, right? This one over here, we have mentioned the name of it. Yeah, this one here, azole. This is azole, but people tend to call this as pyrrole. This is called as pyrrole. So this word is more acceptable even in the international standards. Pyrrole is accepted because beginning from the history, like in early ages, people tend to call this as pyrrole, even though the standard or otherwise the chemically accepted, chemically proposed name is different. It's like azole. People tend to call this as pyrrole. So internationally also this is accepted, and also the compounds like this one. This is called this is furan. And also you may have heard about the quinoline. Right here we have the quinoline. This is quinoline. And also there are indoles. Likewise, there are several compounds that we tend to use the most common name. So just keep in mind on those things also. They are not incorrect, they are accepted. But these are the most standard ways how we name heterocyclic compounds. So I hope it's fine. I hope it's clear to you. If you have any questions, please feel free to comment below. I will try my best to answer those questions. Again, I have to tell you that these are not that much complicated. Just a practice, few examples or few exercises may make this nomenclature more familiar to you. So let's meet on our next video.